This last example using while is a little more complex because I needed to come up with something to introduce the concept of the break command that you see right here. Okay, so we'll talk about what that does as we go through here. This one is drawing a little more upon mathematics, and so don't let your eyes glaze over too much. I'll try to explain it pretty well. The essential thing, what we're trying to do here is determine if a number is a prime number, or if, on the other hand, if it's not a prime number, what's the largest factor of that number? That is, the largest number that times some other number equals that number exactly. Okay, so it's one of those two cases. It's either a composite number or it's a prime number. You remember what the primes are. They're only divisible by themselves or the number 1, right? So our target number, the one that we're wanting to test right here, I've made it equal to 12. We can make it a little more interesting than that. Let's make it 42, for instance. Okay, so the number 42. Now, I know that this is not a prime number, first of all, because it's even, so I know it can be it's divisible by 2. But what would be the largest factor? Well, the largest factor of 42 would be 21, which itself is a composite number and is the multiple of the numbers 3 and 7. So you see 2 times 3 times 7 equals 42. But 21 is the largest number that evenly divides it. That is not the number itself, right? Okay, so what are we going to do? Well, what we'll do is we will come up with a number that we say, well, this might be a factor, and we'll have to test it. And so let's just call that number test. So we come up with an initial number for test, and then while it is the case that, take a look at the while expression, while it is the case that the target number, the remainder of the target number divided by test, that's what modulus means, so target modulus test. And go back and review the modulus operator if you don't remember that one. It's an important one to know. But if the target number divided by test, and if we just take the remainder of that operation, is not equal to 0, that means it did not evenly divide it. So what do? Come up with a new version of test. We'll just subtract 1 from it. And then if it's the case that after we've done that, we're all the way down to 1, well, there's nothing else to check. We've checked all the numbers from the initial value of test all the way down to 1, and none of them have divided this number. And so in that case, we'll break. What does break do? Break causes us to exit the loop, so we don't keep on doing this thing forever. We'll say, hey, once we get down to 1, then we will go ahead and break out of the loop and then continue execution on the next line. And so what does the next line do? Well, if it's the fact that test is greater than 1, then we did find something that divides the number. So we'll say so on this line, right here. Largest factor is test. Otherwise, we say, nope, we got all the way down to 1, and there was no value of test that we found that would evenly divide target. And so we'll say, well, target is a prime number, whatever it is. So how do we come up with the initial value for test? Well, if you think about it, you know that, let's say the number is 42. I don't need to check to see if 41 evenly divides 42 because I know that it can't. In fact, I really don't have to start any higher than whatever the square root of 42 would be. So you can easily convince yourself of that if you just stop and puzzle it for a little while. We only really need to start at the square root of whatever number we're looking for. We can round up from there, and then we'll check every number less than that until we find one that evenly divides it, or run out of numbers to try. That is, we get all the way down to 1 in this case. So see, our initial value of test then takes the square root of target, and we use the bash calculator to calculate that. That's one of the functions built in, if you remember from that chapter. And then we'll simply truncate any of the stuff to the right of the decimal place. So that'll be an adequate place to start. And then we just go down 1 at a time, see on this line. From there, each pass through the loop. So again, the key point of this is the break statement. Break will automatically think of it as breaking us out of the loop that we are in. and not executing it any further. So let's go ahead and put something a little more interesting in here. How about this number, 503, and we'll output that, exit, and let's go ahead and execute, and it comes back with 110,503 is a prime number. In fact it is. That's one of the Mersenne primes. If I change it to something else though, let's just do that and see what we get. And we see that indeed 325 is a factor of 110,500. And so we've gone through both parts or both paths in that code. Okay, so now I'd like to demonstrate another kind of loop, which is the C-style for loop. And one of the problems that you have to do for this week involves using C-style for loops. So I certainly want to make sure that I give you a pretty good demo of how this works. So the C-style for loop, the basic structure looks like this. We have something within a double pair of parentheses like so, which represents the condition, and then a do, and then of course whatever it is that we're going to do, and then done, just like the other loops. So what goes in here? There are three quantities that we put in here. The first is we assign a variable with an initial value. I'll give you an example. I'll say we'll just call our variable I equals 1. And then there's a semicolon and a space. The next thing inside the C-style for loop indicates a terminating position. When do we want this loop to stop? We're saying the variable I starts at the value of 1. I want to terminate this loop when it should be the case that I reaches 11. Okay, so what I can do is say as long as I is less than or equal to 10, we're going to continue executing the loop. And then the last thing is a statement that we want to occur when we get to the bottom of each iteration of the loop. And I'm going to say I++, which means increment I. It's the same thing as I equals I plus 1. I equals I plus 1. So what is this saying? Let's interpret it again. I starts at the value 1. I want to continue to execute the things between do and done as long as I is less than or equal to 10. And every time I execute those things, I get to the bottom, I want to increment I by 1. So after the first time through, I becomes 2. And we say, is 2 less than or equal to 10? Yes. Then we do it again. And then it becomes 3 at the bottom of that second pass. So we say, well, is 3 less than or equal to 10? Yes, it is. So we continue again, and so forth for 4, 5, 6, 7, 8, 9. Finally, when I is 9, we're doing it again. We go through here and do whatever we're trying to do. And then I becomes 10. We go up here, we say, is I still less than or equal to 10? Yes, because it is 10. So we do it one more time. I becomes 11. So we come back up. Is I less than or equal to 10? No, I is 11. So then we continue after the done. So this structure is equivalent to something like this. I could say I equals 1, and then I'll say while it is the case that I is less than or equal to 10, then we want to do the following things, whatever they are, right? And then at the bottom of this, we'll say, for example, how about I equals expression $I plus 1, like so, and then done. So these do the very same things. So take a look at those for a moment and see the similarities and the differences. One of the advantages you'll notice of the for loop is it's shorter. I have one fewer lines inside the loop, that is, this line is not required anymore, and one fewer lines outside where I initialize. So you see the initialization and the incrementing of the variable happen right here. Here's the initialization, and here's the incrementing of the variable. But the condition is kind of the same. So when would you use a for loop? When you're going to do something a counted number of times, it's a more concise way of representing it. So what do we want to do here? How about we do this? We'll just echo I, and we'll do the same thing with the while loop. I'll just echo I in this case to demonstrate that these should do the same thing. And then in between them, I'll say echo, and this is going to be a while loop, okay? Then let me put a header up here too. I'll echo, this is going to be the, we'll call it the C style for loop, okay? And whoops, to delete that, or write it out, and let's execute it. And whoops, I have a problem on line 12, so let's go ahead and edit it, and that's right here. Oh, you see my problem? The usual thing, right? $sign. Okay, let's run that, and you'll see that the C style for loop outputs the numbers from 1 to 10. The while loop does exactly the same thing. So what you can do with one kind of loop, you can do with the other. But you choose one or the other for the sake of convenience. Okay, so now we're talking about this C-style for loop, which has this syntax. If you have programmed in another programming language, then you might have seen something like this style of for loop, which originally was introduced in the C programming language, but instead of the double open parenthesis and close parenthesis at the end, it has a single parenthesis, but otherwise it looks pretty much the same. So one thing to note is, you can also go the other direction. So I could let I equal 20, and I can say as long as I is greater than, or we'll just say strictly greater than 10, and we'll change the condition now to decrement. And let me just get rid of these extra lines in here. Okay, so what is this going to do? Well, I starts at 20. It's going to go ahead and echo whatever I is each time through. And as long as I is greater than 10, it will continue to execute. And each time it's going to decrease I by 1 when it gets to the bottom. So let's trace through it. I is 20. So we start the first iteration of the loop. Is I greater than 10? Yes, it is, because it's 20. Then echo I. So we echo the 20 out. And then we subtract 1 from I. I becomes 19. So now we go back up. Is I greater than 10? Sure, because it's 19. Okay, so echo that. So we echo the 19. We subtract 1 from I, so it becomes 18. And now we go back up. And you can see what that's going to do. 20, 19, 18, 17, 16, 15, 14, 13, 12, 11. When it does 11, it echoes 11. We subtract 1 from I right here. So it becomes 10. Is I greater than 10? No, because I is 10, and 10 is not greater than 10. And so then we're done. So that's going to output the numbers from 20 down to 11. And we can see that operate just like so. Okay, so I went offline for a couple of minutes to put together another one just to keep the video a little bit shorter. And let me show you what I've done here. Wanted to go ahead and demonstrate nested loops, and in fact this is somewhat similar to one of the homework problems that you have, although that one will require some additions and a little more sophistication, but not a lot. Here we'll get rid of that line. So what do we have here? We have a for loop right here. See the structure: for, and then all the conditions and such in there, and then a do, and then a done right here at the bottom. But inside of it, the instructions we're executing include another for loop, and then with the do and then a done. So what are we doing here? Well, here's the way I pronounce this line. It's for I initially is 1. As long as I is less than or equal to 4, do these things, and then increment I by 1 each time through the loop. Okay, so I starts out at 1 the first time through the loop. And so what are we doing? Well, we start another for loop. So what is that one doing? it looks exactly the same. For j equals 1, j is less than or equal to 4, and j plus plus, that means j increment. Okay, so in other words, the first time through this inner for loop, j has the value of 1. So I has the value of 1, j has the value of 1. What are we going to output? We'll echo, dash n means no new line character, so we'll keep it on the same line. Command substitution, we calculate the expression of I times j. Remember the backslash is because we have to escape the asterisk, okay? So what is I times j? Well, it's 1 times 1 is 1. That's rather easy, right? So we're outputting a 1, and you notice there's a trailing space. And then we're done with that iteration of the first for loop, or the inner for loop, I mean, not the first, the inner one, this one right here, okay? But notice that there's an instruction to be executed each time we get done with an iteration. In this case, we increment j, so j becomes 2. Now we check to see, is j less than or equal to 4? Well, yes, it is, because j is 2, so we do it again. But now I is still 1, and j is 2. So what do we output now? I times j is the quantity 2, so we output 2 and a space. And then j becomes 3, and so we do it again, and we output 1 times 3, which is 3, and a space. And we do it again because j is 4, and so therefore j is less than or equal to 4, right? And we output 1 times 4, and a space. And then we increment j, j becomes 5. It is no longer the case that j is less than or equal to 4, and so therefore we continue after the done. We go ahead and echo out this, which will give us a new line character. We get to the bottom here, and what happens? We're to the done that corresponds now to the outer for loop. Remember, I was 1, so what are we going to do? It's I becomes I plus 1. So in other words, I becomes 2. Is it the case that I is less than or equal to 4? Yes. Then we go through the loop again. And so what do? I is now 2, but now we start this for loop as if we've never seen it before. J equals 1. We execute that. And since j is less than or equal to 4, we'll go ahead and do this. So now what do we calculate the expression to be? Well, I is 2, and j is 1, so 2 times 1 is 2, and we output that. And then we increment j, so j becomes 2. We go through the loop again, so now it's 2 right here times 2 right here, so we get 4. And then the next time through, j is 3, so we get 2 times 3 is 6, and the next time 2 times 4 is 8, and then we're done with the inner loop this time. We echo a new line. We get down here, what happens? I gets incremented again. Remember, I had the value 2. It gets incremented to 3. Since 3 is less than or equal to 4, we do the whole thing again. And then there will be another pass after that. So we're going to get 4 lines of output from this. Let's take a look at what it outputs. And there it is. 1, 2, 3, 4, just like we said. 2, 4, 6, 8, just like we said. And you can predict what the others are. It's just like a multiplication table, isn't it? That is done by using a for loop within a for loop. And in this case, we used both C-style for loops to do that. We could also do that with while loops, just as I was showing you earlier. A for loop and a while loop are rather equivalent, but the while loop would take a little bit more code. But just for completeness, I'm going to go ahead and show you what that would look like. What we would have to do is we'd have to say right here that I equals 1. And then we would say, while it is the case that I is less than or equal to, you know, that's going to look like this, right? Less than or equal to 4. So while it is the case that I is less than or equal to 4, we're going to do some stuff and then done, right? The last thing before the done is that we have to increment I. So lots of ways to do that, but I'm going to do it the same way that I've done it before. It'll be I equals, and we'll just use command substitution with an expression, and it's $I plus 1, like so. And that's the last thing that we'll do. So what are we going to do in the middle? Well, in the middle, we'll say this thing called j is equal to 1, and then we're going to use another while loop. We'll say while it is the case that j is less than or equal to 4, we're going to do the following things, whatever they are, and then finally we'll have a done. So what are the things that we need to do? Well, the last thing we need to do before, in this inner loop before we exit is we need to increment j. So j equals, looks rather parallel to what we just did, right? $j plus 1. Okay, and what are we going to do in the middle here? Well, the essential thing to do here now is to go ahead and echo our output, right? So we'll go ahead and echo without a new line. And what do we want there? It has to be the expression that is created when we multiply $I times $j. And I think I have a 1 there, not an I. Let's fix that, or that'll give us trouble. And we'll make sure that there's a space after that. The other thing is that we need to make sure we get, those are all in a row, so we need to make sure that we get a new line character in there, so that'll work. Okay, so now look at the two of them. I believe that those two are equivalent. We'll run it here in a second. Let me just put a blank line in between them, right? So I'll just do it that way. You notice which one is shorter, right? The for loop is shorter, it's more concise, because we've just sucked two lines, like, see, this, for this outer loop, I equals 1, and then this, I equals I plus 1, basically. Those two just get sucked into the condition in the for loop. See it? There's the I equals 1, and there's the increment operation. So it's just much more concise, that's all. That's why the for loop might be preferable when you want to do a counted number of things. But any of these should work just fine. And let's see if I got it right. Yeah, it looks like the same output you see, but this time using a while loop. For our last example, we'll look at a modification of the script that's given on pages 359 to 360, which is looking in the path and finding all of the executable files. We'll make ours a little more specific, but first of all, let's recall what the path environment variable looks like and what it does. The path environment variable specifies the paths to executable files that will be searched when we type something at the bash command line. So even when I type a command like echo or something like that, we can see, whoops, that would be the, I still can't type. You ever have one of those days? Okay, so if I type the which command with another command after it, it'll tell me which one of those is going to run. Notice it's in the bin directory /bin, so from the root, bin directory /echo is the command that will actually be executed. You can see in my path right up here, the /bin directory is one of the things specified. So basically, what the shell will do is it will look in /home/Perry/bin first, and in /home/Perry /.local/bin next, and then etc., etc. See, remember they're delimited by colons in this file. Okay, so we could make a for each loop to go through each of those different paths and list all of the executable files, or search for executable files that match a certain pattern, which is actually what we'll do. All right, but how would we do that? Well, we need to create a list of each of these things such that they were each understood as a separate item in a list. And the way we'd have to do that is we'd have to indicate what delimiter is being used. So let's take a look. Let's see. I think I called this chapter 13 test 25. Let's see. Is that it? That's it. Okay, there it is. So what are we doing here? Well, first of all, we'll establish a target. We want to look for all the executables that match a certain pattern. We're going to keep our pattern very simple now because, as I said, we look at regular expressions and patterns and things a little later in the course. So for now, we'll just say the target equals ment. Any executable that has those that sequence of characters, MINT, in it, because I'm running Linux ment, I expect we'll find some, then I want to just pull those out. I want a list of them and where they live. Okay, so let's ignore this stuff for a second. We'll come back to it. And so what we'll do is say for each directory that's in the path, do the following things, and then down here is done. So for, do, done. Remember that structure, right? And also, we have another for each loop on the inside for each thing that's within whatever that directory is in the path, /star. Remember, Bash will expand that to be a list of all of the files and directories that are within there. So for each thing in dir, if that thing is an executable, and if it's the case that if I execute this command, I'll echo that name, pipe that into grep looking for target. In other words, this condition is true if it is the case that the name of that thing contains this target within it, mint, right? Then that will be true. So if it's the case that it's an executable and it has mint within the name, basically, right, then we'll go ahead and output it. Okay, otherwise we won't. We'll output each of those and with some space in between them, and then we'll put a new line after we've dealt with each directory, okay, to keep the output kind of small. So what about this other stuff? Well, you remember this from before. We've looked at this a couple of times now. But IFS, this is the separator, the set of separator characters that Bash will look for. Usually it's white space, so it'll take a new line character, a tab, or a space as being the separator. We want to make sure that when it parses this path, that it's using a different character. Namely, we want it to use the colon character because we know that those are all separated by colons. We want it to make a list, and every time it comes to a colon, it says, oh, that's the end of one item and the beginning of the next one, right? And so the way we do that is we set the IFS to something. But remember, it's always good practice to save the old one, and then when you're done with it, restore it, because as scripts get more complex, it's easy to forget that you've done that, and then you break something that's somewhere else in the script or in a script that's called by the script or something like that. We'll set old IFS to whatever the IFS variable is. Now we set IFS to what we want it to be, and then when we're done, we'll set IFS back to old IFS. So we basically turn off the lights behind us, right? Okay, so let's go ahead and exit here, and we'll execute. And it's taking a little while to run through this because it's searching a lot of files. But there it is. It took about 3 or 4 seconds. The output is executables containing mint in home/Perry/bin, nothing. And in this one and in this one, it looks like we get one finally here in user/local/bin. There's one, which is mint-SHA-256 sum. Okay, fine. A hashing thing. And then within /user/bin, we have lots of things. Mint backup, another mint backup, mint drivers, another mint drivers, and mint fortune. What is that? I have no idea. There's various things in here. I just put a space between each one just to keep it small. And then in these other directories, of course, you see, nothing there. Okay. So what are the takeaways from this? Why go through this? Well, the first thing is, to show you how we put some of this together, we can easily have Bash take input from an environment variable, and you've seen also how we could read in from a file or something like that. We can have it separate those things any way that we want to based on whatever is delimiting those, whether it's tabs, regular white space, or new line characters like we did in the example in one of the first 2 videos this week, or the colon character as we've done in this case because it's the path variable and that's colon delimited. There are others that are that way too, that are colon delimited. For example, I think one of the examples in the book shows the etc. password file, which is colon delimited field, so you would use a similar structure here. So first of all, how to construct a list from things like that, and here's how you do it. Bash will expand that list for you. Then second, how we use compound conditions. Notice I've got open square bracket right here, close square bracket here. The double ampersand means and then open square bracket, close square bracket. We can combine things like that using and or. So there's a little more on that in the text. But if A and B means both A and B have to be true in order for the if condition to be successful, and so whatever's after the then to actually happen. If one of them is false, then we don't do it. The other possibility there, in addition to and, is or. And or, here I'll just go down to the bottom so I can demonstrate. You've got and, which looks like that, The other one is OR, which is 2 vertical bars. That's that key that's right above the enter key, and it's backslash, right? But if you hold down Shift, it's the vertical bar. So 2 of those means OR, and OR evaluates to true if either one or the other or both of them evaluate to true. In other words, they both have to be false for it to be false, and only one of them has to be false for it to be false. They both have to be true. So we can combine conditions like that to make our code relatively concise. And so this pulls together a few of the ideas that we've discussed all through the videos here. So hope that is helpful, and have a look at the homework, and if there are any questions that you have, any challenges that you have as you go through, then definitely reach out.